Oh, okay. So then I might have to do it like this. Okay, much better. Let's go to the next tab and let's go to rate. Let's go to the rate tab. What do we know about rate? What was rate? You're going to the library. So rate is basically the same thing, okay, as a ratio. You're still comparing two things, okay? But in this case, you're gonna for sure see the two different, types of units, okay? For the ratio, you could be talking about, for example, the one I gave you, boys and girls. I mean, we're all humans, right? It was the same unit, humans. We're talking about humans. If I were to say apples and oranges, well, you're still talking about fruit, right? But now here the rates, now you're talking like two totally separate things. You could be talking about money and pounds. Like if you go to H-E-B and you're gonna buy, tomatoes, and they say, well, 4 pounds of tomatoes is going to come out to $6.50 or whatnot. Now it's two different things. Okay, so right here on the tab for rate, I want you to put, it is like a ratio but the two numbers talk about two different things. And a lot of times the rate, they talk about time. A lot of times it's about time. It's about how much you're traveling in an hour. It's about how much you're doing in a week. It's about, monthly. It's almost always about time, okay? What about a unit rate? We talked about unit rate. What did you all tell me unit rate? What was so special about that? Yeah, unit. Those of you that know Spanish, uno, okay, unit. Yeah, it's always going to have a 1 at the bottom, okay? So the second number, the bottom number in the fraction, will always be a 1. Now, how do you get there to a 1? By using division. So if you don't see a 1, you can always divide by whatever that bottom number is to make sure that you do have a 1 at the bottom, okay? So let's go to the unit rate tab, and I want you to write the following. It is a ratio of two measurements, so two things, where the second number is a 1. The unit rate. So for example, if I said, let me give you an example, that somebody gets $400 in 10 hours. And that's not a unit rate because I don't see a 1 at the bottom. I see a 10, right? So if somebody's making $400 in 10 hours, if you go to work for 10 hours and you end up leaving with a $400 check, my question would be like, whoa, how much are you getting paid every hour to make that much money, right? How could I get that 1 at the bottom? By? Very good. So I am going to divide by 10 And remember, whatever you do to the bottom, you got to do to the top, right? And now I have a 1 at the bottom. And that's going to tell me how much we're making in an hour, right? Who knows what 400 divided by 10 is? 40. Very good. Hey, that's good. That's a good deal. Okay. Questions on that one?
I wonder what John means that.
Oh, you can search it. Questions there? Okay. Now let's go to equivalent ratios. What word did I put there at the bottom? I wrote it myself. It wasn't part of it. What does it say? Proportions. Okay, today we're going to practice with proportions a lot. Okay, so let's go open that equivalent ratios tab and let's put the definition first. What do you think equivalent means?
Equivalent means the same number as another number.
Very good. Equivalent just means it's the same amounts. Same amounts. They might not look the same, but they are the same amounts. Okay, Layla, pay attention. So here we go. I want you to put ratios that name the same comparison. For example, if I said that there was
3 dogs.
40, okay, let's talk dogs then. Let's talk about dogs. That at 2 different parks I rode by, right? I counted all the dogs at 2 different parks, and I counted 40 dogs. That's a lot. 40 dogs in 2 parks, right? And I said, whoa, if there's 40 dogs, let me count the number of cats. And there was like a lot of stray cats there. Guess how many I found?
How many?
60.
Oh, wow.
Right? If I wanted to find another ratio that means exactly that, 40 to 60, what do you think I could do?
Divided by 10.
Divided by 10. What do we call that in fractions? Remember, I always told you, like, always check if you can simplify. That's basically what we're doing. You're simplifying these fractions to come up with the same thing, but they have smaller numbers, but they represent the same thing. So Caden saw that, hey, you can divide both numbers by 10, and now you'll get which ratio?
4 to 6.
Yeah, we'll have 4 dogs to 6 cats.
And
40 dogs to 60 cats. Now in my mind, I'm thinking, every time I see 4 dogs out there, I should expect to count 6 cats. And if I see another 4 dogs, I'm gonna see another 6 cats. That's the relationship. Yes.
I like to do it with also percentages. Like there's 75%, let's just say 10. And you have, so 75% of 10 is 7.5. It's always
Okay.
that.
Yes. Now let me ask you something. Could I keep simplifying? In the 4, 6? Yeah. What could I divide by?
2.
2. So if I wanted to get another equivalent ratio, I could just keep simplifying. And now what do I have?
But you did it wrong. Oh wait, never mind. It's 2 to 3.
2 to 3. Very good. So now in my mind, it's making more sense because now it's smaller, easier numbers to comprehend. So now I know that every time I step outside, if I see 2 dogs, I'm going to end up seeing 3 cats also. Okay? So that's equivalent ratios. You find them by basically simplifying, right? Now remember that I wrote the word proportion in there. Okay? So a proportion is this. I want you to make a little arrow so that you know that these notes down here at the bottom still have to do with equivalent ratios. So here's how we use equivalent ratios and proportions to solve problems, okay? What if I told you that we have 4 dogs, right? For every 6 cats. And what if somebody asked me, all right, let's see if you're smart. And they asked me, what if you ended up seeing 18 cats. What number of dogs would you expect to see? That's a proportion. A proportion gives you a ratio on the left, a ratio on the right, but except it's always missing a number. It could be missing the top, it could be missing the bottom, right?
12.
12? How did you get that? You're right. How did you get it?
Multiply 3.
Ah, he saw the pattern. He said, I see that 6 times 3 gives me 18, and we know the magic rule of fractions that whatever I do to the bottom, I got to do to the top. So if 6 times 3 is 18, what's 4 times 3?
12.
Ah, very good. So let me show you. So now you know that this one's going to be 12, right? Well, what if the numbers were not like super easy to tell? Like this one, because it was the first example, I said, let me give them easy numbers so they can see that it's times 3, right? But what if I gave you something like this? What if I said this proportion? X over 4 equals 18 over 30. Ah, now our brain is kind of like, oh, we don't know what to do because 4 times 7 is 28. 4 times 8 is 32. Darn it. It's hard. It's hard, right? It's harder to think of that number. So then you don't have to be breaking your head, thinking about it. There's a special way to solve a proportion. Does anybody know how to do that?
Simplify the
We could use simplification, but let's say we just couldn't. How do you solve a proportion? You all know how to solve proportions? So let me show you how. You are going to do what I guess some teachers call it the butterfly method. Okay? So they do this. You see these two? You are going to multiply those two. Somebody tell me what 4 times 18 is.
It's
72.
72?
71.
72, right? And then this one, you see this one left over? You're going to divide your 72 by that.
By 4? Oh,
No, by the other number.
by 4.
Okay? So somebody divide 72 by 30.
2.4, miss.
2.4? Let's see. What's 2 times 30?
60.
What's 72 minus 60?
12.
12. Pay attention. Put a 0 and bring it down. What's a 120 divided by 30? It's 4. Ah, no wonder. No, it's not 24. It's 2.4.
The decimal.
Don't forget the decimal. Okay? So, how do you solve a proportion? You multiply and divide. Okay? You cross multiply and divide. I want you to memorize that. Proportions, cross multiply, and divide. And that's how you're going to get the missing number. Okay? Questions on this? All right, so now what I want you to do, you don't have to do it right now, but make sure you spend some time. You put glue on all this back and you glue it, or you can put tape, right, and you put it in your spiral. So put this one to the side. No. Trash can be thrown once you guys are walking out of here, okay? So let me. Now we're going to take our last set of notes together. And after I take these last set of notes, comes the independent practice.
What's an independent practice?
Sit down.
Wait, I'm looking for glue.
No, I said not right now. Okay. Listen, listen, listen. All right, so we're going to take our last set of notes. And I want you to ask questions if you get stuck. After these notes, notice what I have for you. Solving proportions. How do we solve proportions?
Divide.
Cross multiply and divide. All right. It doesn't have any left? Go ahead. All right, here we go. Let's start on the right side where it says ratio. So I put the little definition there for you already. You're welcome. It says a ratio is a comparison of two quantities. Okay. Sometimes you can be talking about a part to the whole. What does that mean? Okay. Remind me. How many boys did we say we had here? 11, right? So the part, because you guys are just part of this class, because we're missing who?
8 girls.
The girls, right? So the part would be the boys. 2, the whole would be the whole class. Well, if we had 11 boys, how many girls do we have? 8. What's the whole? 19, right? 11 plus the 8. So we would say 19 students because that's the whole class.
So 19.
Now, sometimes they want to talk about backwards. They want to talk about the whole class first and then a part of the class, right? So remind me, how many students in the whole class? 19. And if you don't mind, I'm going to use the different ways of writing the ratio. So in this case, I'm going to use the colon, the 2 little dots, okay? So 19 students. And now let's talk girls. How many girls? 8. So let's call that the part. 8 girls. And then a ratio can also compare part to part. Part to part. So now let's talk about how many girls. 8 girls. To how many? What's the other part? The boys. How many boys? 11. All right. And then, of course, I remind you of the different ways that you can write a ratio. Say correctly, please.
Okay.
You can write it with the word 2. You can write it with the 2 little dots, or you can write it as a fraction. Okay, and they all mean the same thing. And guess what? You read them exactly the same way. A to B, A to B, A to B. Okay, so it just looks different, but it's the same thing. So let's do an example together. What is the ratio of circles to triangles? So, hold on. Roy, who's the first shape they mentioned?
Triangle. Oval.
Roy.
The first shape that I mentioned,
Where? Are you with me? Because you're not focused.
oh, the ratio of circles and triangles is 2 to
No, circles. How many circles, Roy?
4.
Okay, so that's what I want first. Because the word circles was mentioned first, you are going to count how many circles, and that's 4. 2, triangles was mentioned second, so you give me the number of triangles second, which was
2.
2.
4 to 2.
So the order matters. If they say circles to triangles, you better be giving me the number of circles first. If you write 2 to 4, is that the same ratio? No, because 2 to 4 would mean they wanted triangles to circles, which is different. Okay, so make sure that you guys read carefully, and whoever they mention first, you have to write first, okay? All right, Layla, if I want the ratio of triangles to circles, give me the numbers. And you're going to keep using the same little picture right here. Yes, triangles to circles. Give me the triangles to the circles, Layla. Triangles.
To circles.
I don't know.
How many triangles do you see?
4. I don't know.
Triangles.
2.
The triangles. 2. Okay. So 2. Since it was mentioned first, guess what? It's the top part of the fraction. And then Layla, how many circles? 4. All right. Let's see. Let me have back there. What's your name, sweetheart? Julio. Give me the total shapes. Oh, this was tough. Total shapes to the triangles. Everybody agree?
Yeah.
1, 2, 3, 4, 5, 6 total shapes. Very good. To the triangles, only 2. Very good. All right, Liam. Circles to total shapes. 4 to 6. Very good. Questions on ratios?
No.
You sure?
Yes.
All right. Now let's go to the middle. Let's continue talking about unit rate. I made sure I put the little reminder that units rates are special because they have a 1. That's the second number, not the first. The second number will always be a 1. Roy, are you listening? Okay, so make a little note. The second number will be a 1. Don't get it confused. If you see a 1 on the first number, that's not a unit rate. It's got to be the second number. It's got to be the bottom on the fraction, okay? So look at some examples. John buys 12 apples for $7.80. What is the price per apple? How am I going to write this ratio if they're telling you per apple? You see this part right here? Underline it for me. This is fancy for 1 apple. So guess where that 12 goes if eventually I'm going to want that apple to be a 1. Am I going to put it on the top of my fraction or the bottom of my fraction?
The bottom.
Bottom, because the unit rate always has a 1 at the bottom. So you have your 2 numbers, right? This one and this one. And even though in the word problem, you see the word 12 apples being mentioned first, we're not going to put it on the top because the word problem keeps telling me that at the end, I want to know the price per apple. So that's already your hint. I want the apples to be the 1. So that's your hint that it's going to go at the bottom. So I'm going to put $7.80 on the top is what 12 apples cost you. But I want to know the cost of 1 apple. What does that look like? What do we call that? A proportion. So remember, proportions, sometimes they're easy numbers. How can I get a 12 to be a 1? That's pretty easy. What do you have to divide by? 12. 12 divided by 12 would be 1, right? So this one's easy. I can divide this one by 12, and that's going to get me my 1. Okay, Roy, what do I have to do to the top?
To the top, we're gonna have to divide it by 12.
Very good. I'm going to have to divide it by 12 also, and that's going to get me my top number.
That's 65.
So somebody put, those of you with a calculator, put $7.80, 7.80 divided by 12. What do you get?
Oh, I got 0.65.
Okay, somebody check his work. Correct? Good. So what does this mean? What does that mean? Because what was the question asking?
Price.
So what does that mean? Very good. So how much is each apple?
65.
Very good. So make a little note. Each apple costs 65 cents.
That's pretty cheap.
That's cheap. All right, questions there? All right, let me have Ricky. The next one says that a car is traveling 135 miles in 3 hours, and I want to know how much it travels each hour. So who do I want to be a 1? The 3, the hours, very good. So put right here, make a little note that I want this one to be the hour. So because I want that one to be the 1, where is it going to go in your ratio? Top or bottom? Very good. So make a little note like this. So I'm going to start. 135 miles over 3 hours. And I want to know how much it's traveling per hour.
Divide by
Very good. We're going to divide by 3. Huh? You get 45? Let's see. 4 times 3 is 12, 15. Very good. 45. So what did we just answer? We answered that a car is traveling 45 miles every hour. Now that you know this, I could ask you, how much are you going to travel in 2 hours?
Teachers, excuse this interruption. At this time, keep your students in second period until we make an announcement. All students should remain in second period until we make an announcement. Thank you.
Okay, so if you know that a car travels 45 miles every time an hour passes by, well, what if I want to know, Roy, how much you're traveling in 2 hours?
90. 90.
Yeah, how'd you get that?
We
You're right. How did he get 90?
multiply.
Times what?
2.
Very good. Yeah. Now I can just do times 2. That gives me the 90. Maybe the teacher's going to ask us, hey, how much are you traveling in 10 hours?
Imagine. Oh.
How many miles in 10 hours?
450.
450. Very good. You see, that's why unit rates help you so much, because then you can figure out any value. Okay? All right. Let's have Ryan. Tony pays $11.90 for 1.4 pounds of coffee. What is the price per pound of coffee? Who do I want to be my 1 at the bottom? What? Well, look at the question. Which one has the per? Yes, it's the per pound. So it's going to be this guy that I want at the bottom because I want to change it to a 1. Okay, so make a little note here that this is what you're looking for because you want to know how much it costs for 1 pound. Okay, so I need the pounds to be at the bottom. And remember we said that it's not always easy numbers, right? But we know that we're going to end up dividing 1.4 divided by 1.4. That's going to give you a 1.
Mr. Medium,
Yes?
by the way, are we gonna do at least like 2 by ourselves?
Hold on. Be patient. All right. So last week, you covered dividing decimals. And that's the reason why teachers do this in a certain order, because if we hadn't covered that, how can we solve this, right? So we have to divide 11.90 by 1.4. Okay? And those of you that have a calculator, well, that's easy, right? But we still need to know how to do it by hand. So 11.90 divided by 1.4. What's one of the major rules when you're dividing decimals?
Bring up the decimal.
Yes, but can I have a decimal on my divisor? No. This guy on the outside, when you're dividing, can never be a decimal. So I need to move this guy over to make it a 14. But it's like fractions, right? Whatever you do to this guy, you end up having to do it to this guy. So if you moved it 1 space, I need to move it 1 space. So now it becomes what number? 119.0, but do I really need the 0 though? Nah, it's the same thing as just 119, right? So then we start the dividing. 14 obviously is not gonna multiply times anything to get you 11, right? So we're gonna just end up looking at the whole thing. So 14 times what? What should I start checking? My mind always goes to 10 for some reason, right? So 14 times 10, am I gonna go over? Yeah, I'm gonna go to 140. That's too much, right? So now I know it's lower. So what do you want to check?
7.
7?
7.
Okay. What's 7 times 4?
24. Oh, 28.
Yeah. And then 7 times 1 plus 2. All right, I'm pretty close, but I want to be sure. So what am I going to check next?
8
Mhm.
times 8.
So 8 times 4.
32.
Carry the 3. 8 times 1 plus 3. Am I going to be able to do times 9, or do you think I'm going to go over?
9.
Because look, 112, to get to 119, I only need 7 more. Do you think I'm going to be able to fit another 14? No. So it's going to be 8. 8, subtract. What's 9 minus 2?
7.
7, and then this cancels, right? Now here comes my 0. 70 divided by 14?
What?
5. Very good. That's exactly 70.
It's
Good.
I figured it out.
All right, so let's put the answer here. What do we get? 8.5. Wait, but hold on. What does this mean? What is the price per pound? What does this mean?
1 pound. 80.
1 pound costs you what?
85.
8.5.
But think money. How much money is this?
$8.05. 50
Ooh.
cents. 50 cents.
Yeah, why not 5?
Because it's in the tax place.
Yeah, you see, $8.05 would end up having a 0 over here. We can add zeros at the end, right? So it would be $8.50. Make a little note. For every pound of coffee. So always make sure you know what your answer is representing, okay? All right, next part. We're almost done. And we're going to continue with proportions. Notice right here, these are just little definitions that I went ahead and I put as reminders. Proportions, again, is when you place 2 ratios with an equal sign in between because they're equal to each other, right? And you solve them by doing cross multiplication and then division, okay? So right here, look at the sample questions. It's asking, are these ratios proportional? Are they going to give you the same thing? Are they equivalent ratios? Well, how can we check? How can we check if these 2 guys are the same equivalent ratios? What would you do to check if 2 fractions are equal? What would you multiply?
Making the bottom one 10 times 3 equals to 30.
Good. So if times 3 worked at the bottom, if these are proportional, the times 3 better work on the top. Does it? Yeah. So if I do times 3 down here, and I do times 3 over here, does it give you this guy? Yeah. So then yes, these are proportional. You want to know an easy way to compare fractions? Because remember, we don't always get like super easy numbers like these, right? But let me show you an easy method there.
What's
Okay.
what's that number?
What number?
4 over 6? I can't see the light.
Okay, then sit over here.
Yes.
So are they proportional? Yes. Okay. So let's look at the next proportion, and I'm going to show you a little easy way to check, right? Because right here, we're going to get stuck. We're going to be like, does 3 times anything give you a 10? Leila? Does 3 times anything give you 10?
No.
Well, that's where you're lost. And if we're lost, guess what? That means you get to go eat lunch in detention so you can review the video. So does 3 times something give you a 10? No. What's 3 times 3, guys?
9.
9. What's 3 times 4?
12.
So we never get a 10. You see right here? So then we're stuck. So here's how you check right away whether 2 ratios are going to be proportional. You do this. What's 3 times 6?
18.
18. And then you do it this way. What's 10 times 2?
20.
Do you get the same number on the top? Same answers? No, one's a 20, one's an 18. So guess what? These are not proportional. Look at this one. 10 times 15. How much?
150.
150. 30 times 5.
150.
So that's why this was a yes. Because when you do cross multiplication, you ended up with the same answers. Okay? Let's go to the last 2 examples of this little section. 3 to 4. Remember, I can write them like this. 3 to 4. And I'm checking to see if it's proportional to 8 twelfths. What do you think? Let's cross multiply. Somebody tell me what 4 times 8 is.
1 times base 32.
Very good. What is 12 times 3? Are these proportional? No. All right, write all these down. This is the time where you should be asking questions because guess what? You're not asking question. Guess what Mr. Trevino's thinking?
You know it.
Everybody's getting it. So we're going to move on faster and faster and faster because you're getting it.
I feel like this is
So,
very-
That's why right now when it's guided notes, you write everything down. You ask questions. This is the time to make mistakes because right now I'm going to start giving you the independent practice. Okay? Here we go. Ryan, 20 times 6. How much? 120. Very good. Roy, 30 times 4.
30 times 4.
Do it on paper pencil, Roy. That's why we have paper pencil.
160.
Paper pencil.
I know. 120.
120. Because 4 times 3 is 12 and then place the 0. So are these proportional?
Yeah.
Yes. 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 Quick. Nice answer. Did you ask? I said. All right. Last section. And you might be thinking to yourself, oh, Miss, is there so many notes? Yes, because remember, this is new concept. I want to do as much as we can with you so that you're ready to do it by yourself. Oh, yeah, exactly. All right, here we go. Solve the proportion. So how do we solve proportions? Cross multiply and divide. So I want you to make that little note so that you know what to do. Proportions, cross multiply, and divide.
Miss, that's our reminder.
Yes. So here we go. Cross multiply. 6 times 20.
6 times 20 is?
Yeah.
That's 120.
Very good. 120. And now I'm going to divide it by what?
By 5.
By 5. The other little number I haven't used.
Miss, I did this last year, Miss.
You did?
Yeah, and I was
Good.
like confused because I say, did I multiply first or I divide first?
Yeah, multiply and then divide.
Yeah.
So 5 times what gets you close to 12?
This it equals 14.
Well, hold on. 5 times what gets you
Oh,
close to
2.
12? 2, right? What's 2 times 5?
2, 10.
10. Subtract, you get a 2, and you bring down the 0.
Oh, that's easy. Miss.
So
That's
what
four.
times 5? Very
24.
good. So then that equals 24.
Miss,
Yes, by the way, dividing is so easy.
Good.
Before, it used to be super hard.
All right. Next one. Cross multiply. 4 times 9,
Oh, that's 36.
36, and divided by 12. What's 36 divided by 12?
And then, my 3.
Very good, yeah. So there's your answer. Super easy, right? So I put the question just because the whole independent practice has to do with this. How do you solve a proportion?
Why didn't you
Multiply.
But which one do we do first?
Multiply and then we divide.
Good. So number 1, cross multiply. Step 2, divide. Last 2 examples. And then it's going to be your turn to show me what you got. Ready?
Yeah.
Ramsey uses 5 grams of tea leaves to make 18 fluid ounces of tea. Last week, he made 126 fluid ounces of tea. How many
I know what to do
leaves
now.
did they use?
Miss, I know what to do.
Oh man, why are there 3 numbers?
Oh, I know, Miss.
Why?
Because we have to multiply and then divide, right?
Very good, because there's actually a proportion here. So
To multiply.
anytime, listen up, anytime you see 3 numbers, remind your brain that there's a proportion. There's going to be a fraction that's complete. You have both numbers, but then there's going to be a fraction that's going to be missing one of the numbers, right? So let's look back at the problem. Tell me which 2 numbers are mentioned together.
5 and 18?
5 and 18. We know that when he made or she made 5 grams of tea, she used or he used 18 ounces.
Miss, like, this is like when we did the 126. One, can we put like the X on top or down?
Very good question. I'm glad he brought that up. He's like, okay, I know that the 126 is the number for the other fraction, but where am I going to put it? What's your name back there?
Ivan.
Huh?
Ivan.
Ivan? Okay, Ivan, help me out here. I know that 5 grams of the leaves made 18 ounces of tea, but now I'm confused. Where am I going to put that 126 ounces of tea? Top or bottom?
Shouldn't be on the bottom.
Why? Not because it's a bigger number, but why?
Oh.
Because 18 and 126 are both fluid ounces of tea.
Very
That's
good.
the variable.
Because I made a decision
Oh.
that when I wrote my first fraction, you see, that's why this part, labeling your numbers is so important, because I made the decision of putting ounces at the bottom. So now that they're giving me another number for ounces, I gotta be consistent. If I put ounces at the bottom on the first fraction, I gotta keep putting it at the bottom for the second fraction, okay? So because 126 represents ounces, I check my first fraction, I put ounces at the bottom, therefore it goes at the bottom. Very good question. So now how do I solve that?
First,
What am I gonna multiply?
5 times 126.
Very good. Cross multiply. So we're going to do 126 times the 5. 5 times 6,
30.
carry the 3. 5 times 2,
10.
plus 3,
13.
carry the 1. 5 times 1,
5.
plus 1.
6.
And now I'm going to divide 630 by the other number I haven't used, 18. 18 times what gets you close to about 63?
Maybe 4.
4?
3.
Maybe 5.
Well, let's check. Okay, if you say 4, somebody do 18 times 4 for me.
18 times.
72.
Yeah, I'm already over. So what's 18 times 3?
That's
54.
18. Wait.
54.
No, never mind.
54? What's 63 minus 54?
That's
9. Bring down the 0. What's 90 divided by 18? 5. Very good.
35.
So what does this mean if the 35 is on top? It's 35 what?
35
35 grams of the tea leaves. In order for you to make the 126 ounces of tea, you ended up having to use 35 grams of the leaves. Because they might ask you what the number represents. Okay? All right, do me a favor while I talk to Ms. Trevino. I want you to set up your proportion here. Set it up and solve it. And then that's the last problem we're going to do together. Wait till.
This ought to be 50. Itsy bitsy spy.
What happened to your old water? What happened to your What happened to your old water?
I got a little bit too much.
You broke the other one that was $70.
No, I haven't. I want to say I have regular water.
Sell that glass bottle. You don't need to waste $70 on a glass bottle. I have glass bottles that look exactly like yours for $5.99.
They finally fixed it. I came in this morning from school.
It's not cool. Now it's
Okay with it.
so that was the first year. I was like,
It's fine, it's a breeze to me.
I have 3 bottles that I did.
Because I go in the ice bath every day.
So cold.
All right.
No, you don't.
Who wrote down the proportion?
Me, but
Okay.
I did
Go ahead. Tell me this one. What did you write?
minutes,
Yes.
35
Yeah,
miles,
Yes.
and then down we have to put 2 hours. Well, 2 hours.
2 hours. Very good. And then the next number was half, right? That's okay. That's half, right? So no, you would have to use the number half. So where am I going to put it? Top or bottom?
Teachers, at this time, please release students to third period.
Bottom.
Why?
Teachers, again, at this time, please release students to third period. Thank you.
Miss, because it says 1/2 an hour. And then
Hour,
it
and
says
we
2
have hours, right? Very good. So I'm going to put half right here.
What?
Why are you gonna put one?
Okay. So how do we solve a proportion?
We wait. I think I know. Like I think we saw 1/2 times 35 over 1.
Yeah. Now it might look a little funky, right? But give me the decimal form of this guy.
0.5.
Yeah. So if it's giving you trouble looking at it like this, well then think of them like this.
But
You know? And then you just have to multiply decimals. What have we done, right? So you would have to do 35 times 0.5. What do you get?
17.5.
17.5. And then divided by 2.
But miss, like the 2 doesn't have a decimal. We don't need it.
So no, you're good like that. So
But we had to put the decimal on top, right? The decimal.
yes.
Wait,
Yeah, you would have to
why
just
are we dividing like this?
like how?
Like that, like why are we using 2 point hours, all of this stuff? We didn't use that before in these.
Because
It's the same thing. We've been doing proportions.
I know, but why is it 2.5 instead of just a fixed number like 30 or 20 or stuff like this?
Well, why not? It's a number. I can give you the number 3/4 if I wanted to.
That's 0.7.
And it's 0.75. It's just a number. Okay?
But why don't you just put 0.5?
17 is 8.
Very good. So 8 times 2 is 16. That's a 1 when you subtract. Bring down the 5. What's 15 divided by 2? 7. That's 14. Subtract. and bring down a 0. Very good. So 8.75. Questions there? You sure?
Yeah.
Roy? Questions?
I finished. Yeah, I like it.
Okay.
So
Here's what you're going to do. Shh, listen up. You've got this guy to glue down. And this one, this is what I want you to do. You fold it like little curtains like this, like a little window like this. And then you glue them down too, because these are your notes, okay? You put glue right here, and you just glue it down also in your spiral. So you should have 2 of them. And listen, tomorrow Mr. Gonzalez is going to check. Let me see your spiral. And he's going to want to see these 2 glued down. Okay? And now, here's what you're going to do for the remainder of the period. You are going to have a ton of proportions. And all you got to do is cross multiply and divide. Yes?